Bio-oils also will contain organic carbon components like alkanes, alkene, alkynes. Only thing is, uh, you will not get the same way what is there in the crude oil, like like the cyclic components, a long chain component. For example, if you want diesel, we wanted a linear chain components. If you want a fuel, you wanted like a branched components. Those kind of exact composition will not be there, but still it has a similar characteristics like a crude oil, and it can be used as a liquid fuels. From the biomass, it contains certain extractives. Like I said, if you have eucalyptus plant, you can extract eucalyptus oil. It depends upon the nature of the biomass. If it contains oils and gums, and using the simple extraction process with solvents like methanol, ethanol, you can extract those extractives like turpentine and etc. If you also take biomass, if you do fermentation means enzymatic reaction. You will learn more in your biochemical engineering course. So you take the biomass, put some required amount of enzymes, and put it in autoclave reactor. Then you can also produce ethanol, butanol, lactic acid, hydrogen, methane, etc. Depends on the enzyme what you're using. You can produce different types of products. I think, yeah, record. Next one is hydrolysis. Hydrolysis means reacting the biomass with sulfuric acid or HCl, hydrochloric acid. Hydrolysis means uh, carrying out these reactions in the presence of this concentrated acid to break the bonds. If you do that one, if you do that one, depends upon the way you perform the hydrolysis. You can perform amino acids that gives you uh, ethanolamine, styrene, butanediol. You can produce same components. You can get these components even from the petroleum components or products also. Now, if you do hydrolysis at severely at 350 degrees centigrade, then the hydrolysis produces aqueous sugars. Aqueous sugars that leads to produce from those aqueous sugars you can produce sorbitol, xylitol, isorbidite and HMO. These are the very important solvents used in the pharmaceutical industries. Pharmaceutical industries. Of course, each one, gasification itself a big topic, pyrolysis itself a big topic, fermentation itself a big topic. But I am here we are not, of course, in this course, in the CPT course, we are not trying to understand the processes very deeply. We are trying to understand the overall process flow sheet. Overall process flow sheet. Now, what are the things? Why is that we will able to produce? Why is that you're able to produce all these components? The main reason, the simple reason is that biomass contains cellulose, right? This cellulose is basically glucose molecule. Glucose molecule. So this is each glucose molecule is bonded. One glucose molecule to one glucose molecule, there is a bonding between hydrogen and carboxylic group. Hydrogen of one glucose chain binds with the carboxylic group of the other molecule. That way, basically biomass is basically a simple sugars. Sugars contain carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. So basically the fuels, whatever hydrocarbon fuels we are taking, it contains carbon and hydrogen. But biomass contains this is in excess. Biomass has oxygen. Whereas crude oil contains only hydrocarbons, carbon and hydrogen only. But biomass contains addition carbon, hydrogen, oxygen. So some cases this will become a positive advantage, sometimes it will become a negative advantage, negative side. So, so since it contains hydrocarbons, when you manipulate this biomass in a different way, we're able to produce different products. We're able to produce different products. Like for example, if you do hydrolysis, what this hydrolysis does is that it breaks all these intermediate bonds. It will break this all intermediate bonds. Then you will get only the sugars, dissolved sugars, the dissolved sugars in water. Now, if we add a specific catalyst, then you can produce these components. If you add specific catalyst, you can produce these components. So, biofuels, very well-known biofuels is bioethanol and biodiesel. Bioethanol and biodiesel. So, how do you produce these bioethanol? This slide gives you a quick process which to produce the bioethanol. So if you take lignocellulosic biomass, biomass is also biomass which contains cellulose, lignin, hemicellulose, which is also called as ligno. This is lignin, right? Lignin, cellulose. Some biomass won't contain lignin, like cotton. Cotton contains only cellulose, doesn't contain lignin. So biomass which contains lignin, which is all biomass will have cellulose, definitely. All the biomass will have cellulose. But some biomass can have lignin, some biomass may not have the lignin. One example is cotton. So lignocellulose biomass. Lignocellulosic biomass means a biomass which contains lignin, cellulose, and hemicellulose. That is the name here. If you feed, if you do pre-treatment, with chemicals or simply heating, you can produce two things. One is you can isolate the hemicellulose from the cellulose and lignin. Let me explain. If you remember, these are the lignin flakes, and here we have the cellulose chains. These are the green color cellulose chains, and we have the hemicellulose is bonded. Hemicellulose is bonded like this. So this is hemicellulose, and this is lignin, and this is cellulose. So this wood, the lignocellulosic biomass, cut into small pieces. It is cut into small pieces. So this is called wood chips. These are called the wood chips. This wood chips crushed into very fine particles. These wood chips are crushed into very fine particles. Fine particles. So if you place these fine particles in a beaker, and if you put a hot water, if you pour hot water, roughly 130 degrees centigrade, and mix it. If you pour water, then mix it using like a CSTR. Mix it. What will happen is you just understand the lignin, cyclic aromatic phenolic components, which won't dissolve in any most of the solvents. Cellulose dissolves in organic solvents and strong acids. Hemicellulose, easily dissolvable glucose molecule. So that dissolves even in water at high temperature. So just one second. So, so if you pour water here and if the water is at high temperature, since hemicellulose is easily dissolvable sugars, what will happen is the sugars are extracted, the sugars are dissolved, the hemicellulose sugars are dissolved in water. Hemicellulose sugars are dissolved in water. So if you mix it after some time, let's say half an hour, what you will get is you will get fine particles, fine particles, and you have this this suspension. It contains the suspension contains water and hemicellulose. Water and hemicellulose. What happens is, this is where the beauty of chemical engineering, mass transfer and all comes. If this is a particle, I'll just keep it here. This is a particle, and this is a porous particle. This is a porous particle. Woods are porous particles. Wood particles are porous particles. And this is surrounded with water. This is surrounded with water. This is hydrophilic particle and also porous particle. What will happen is water will diffuse. Water will diffuse. Water will diffuse. So this is the water molecule, and this is the pores, like the molecule of wood. As soon as this interacts, as soon as this water interacts with this the biomass particle, what will happen is cellulose, it interact with cellulose, it interact with lignin, and interact with hemicellulose. And out of these three components, one is soluble and other two are not soluble. So the solubility of hemicellulose is higher in the water than cellulose and lignin. Almost the solubility of cellulose and lignin is zero. So then obviously what will happen is, as it penetrates, the lignin will diffuse, dissolves, soluble in water. The lignin gets, so hemicellulose gets dissolved in water. Hemicellulose gets dissolved in water. As soon as this water contains hemicellulose is increased, the concentration of hemicellulose here is higher, whereas the surrounding water is lower. So again, it will diffuse outside. Again, it will diffuse outside. So this is the beauty. The whole phenomena we explain chemical engineering is the unique and beautiful, which doesn't explain any other engineering subjects. So that way, after the pre-treatment, we get the hemicellulose out from the cellulose and lignin particles. We take out the hemicellulose by using the simple treatment. If I use water at 130 degrees centigrade, I can extract this hemicellulose. If I don't want to heat it, if I wanted to do at the room temperature, you can add HCl and water. You can add HCl, one normal HCl. You can add one normal HCl. You will be able to extract it. You can also add, so many solvents are there. There are multiple lists of solvents are there which can extract hemicellulose from that water. But extracting with water is more cheaper and more easy. We don't need to separate the solvent after the pre-treatment process. So that way we get the hemicellulose out. Then we have the cellulose and lignin particles. Let's say after that one we will separate the liquid and particles. The particle contains lignin and hemicellulose, and water and hemicellulose comes outside. So this hemicellulose that is, this hemicellulose is already dissolved. The glucose molecules are already dissolved. One type of hemicellulose is xylose, so it dissolves in water, right? It dissolves in water. If you add certain catalysts, like after dissolved hemicellulose is there, if I add catalysts like sulfuric acid, and if you catalyze like sulfuric acid, and if you perform reaction, you can produce chemicals like HMF, hydroxy methyl furfural. We can also produce levulinic acid, LA, levulinic acid, that is one type of chemical from this, with this help of this catalyst. Here H2SO4 act as a catalyst after dissolving the sugars. You can produce these chemicals. If you do this hemicellulose and add certain enzymes like cellulase, the enzyme name is called cellulase. The enzyme name is called cellulase. Cellulase. If you add this, if you take this hemicellulose dissolved water and add this cellulase enzyme, add the cellulose enzyme, add the cellulose enzyme, and we have a reactor which is almost like a pressure cooker, a very tightly closed reactor that's called autoclave reactor, that we call autoclave reactor. And if you add this hemicellulose dissolved water and add this enzymes and heat it to certain temperature and leave it for a longer time, like 16 hours or 24 hours, then all the dissolved sugars are converted to ethanol. All the dissolved sugars are converted to ethanol. So this is the way you can produce chemicals from the dissolved hemicellulose. You can also produce ethanol from the dissolved hemicellulose from the lignocellulosic biomass. Students are able to understand what I am trying to explain. If anyone say yes, that will be good. If you understand, you say yes. If you don't understand, you keep quiet. Okay. Anyway, I think I should have not asked this question. Yeah. So we have cellulose and lignin, which is still presented in a particle form. Because why this is still remain as a particle form? Because the water at 130 degrees centigrade is not sufficient to break the bonding. Why this is holding as a particle? Because of the strong bond between the glucose to glucose molecules. Because of the strong bonding between the glucose to glucose molecules in cellulose and phenolic component to phenolic component in the lignin. So to break the bonds, we have to do the hydrolysis. We can do hydrolysis either with enzymes or with acid. Hydrolysis basically simply breaking the bonds between glucose chains in the cellulose and the bonding between the phenolic components present in the lignin. So to do this hydrolysis, if you want to do the acid hydrolysis, you can do H2SO4, you can add H2SO4 and heat it. You have to do almost 33% concentrated H2SO4, or we can add HCl. HCl has high pKa value, so you don't need that strong acid. So you have to add, you will take 2 normal or 3 normal HCl. Then you heat it temperature between 350 degrees centigrade. If you maintain these conditions, then only the bonding between glucose to glucose molecules in the cellulose will take place. That is called hydrolysis. Other way is you can also add this cellulase enzyme and leave it in the autoclave reactor for longer time. That is also do the hydrolysis. So once you perform this hydrolysis, if you maintain these conditions, only the glucose molecule bonding will break. The lignin bonding will be difficult to break. Lignin bonding, or the bonding between phenolic molecules in the lignin, is very difficult to break. So you have, once you break the bond, all the cellulose is converted to glucose. All the cellulose is converted to glucose. The lignin bonding will not be broken down. Lignin bonding cannot be broken down using the whatever hydrolysis content I have mentioned. So lignin will come out. The lignin will come out and dissolved with glucose will come out. This glucose again you can do the fermentation. You can do the fermentation. Fermentation, it will convert to the ethanol and some other components will be there. To separate ethanol from those components, we have to do the distillation. you have to do the distillation. So the separated lignin can be purified and can be sold as a lignin. Lignin itself has a market value because this is a hydrophobic flake-like particles. This will be used in many applications. Or you can also burn it and you can do the power generation. You can burn it and you can do the power generation, which I showed in the craft recycling process, how the lignin is burnt, the black liquid is burnt to produce the power. The same method can be used. So this is all about bioethanol or biodiesel, both the same, bioethanol production. So this is biodiesel production. Biodiesel production from the oils and fats. Biodiesel production from the oils and fats. This is another source to produce biodiesel. This is the another source to produce the biodiesel. I think this is also well known for quite long time. So oils and fats are pre-treated to remove any presence of salts. Oils and fats are pre-treated to remove any presence of salts or any other oxidative components. After this pre-treatment, methanol catalyst is added. Methanol catalyst is added. Here, this trans-esterification process is taking place. So here, see, this is the typical reaction. So this is the typical formula of vegetable oil. Vegetable oils predominantly contain triglycerides. Vegetable oils contains triglycerides. So triglycerides, a branched triglyceride components will be there. So we have the hydrocarbon CH2 and triglyceride components are there. When you react this vegetable oil with methanol, CH3OH, in the presence of catalyst, these triglycerides, these three components are converted to fatty esters. Converted to fatty esters. These are converted to fatty esters. So this is mixture of fatty esters, and you will get glycerol. You will get the glycerol. You will get the glycerol. So we have fatty esters and glycerol. So that happens in the transesterification process. Transesterification process. So here we wanted to separate this glycerol. We want to separate glycerol from the fatty esters. We want to separate the glycerol from the fatty esters. So phase separation. Actually, fatty esters and glycerol can be easily separated. One is fatty esters in oil components, the glycerol is a liquid-like component. So once you after this transesterification, you have the fatty esters and we have the glycerol which are separated. One is fatty esters are oil-like components and glycerol is like a water-like component. So simple phase separation will do. So after phase separation, the fatty esters goes this side and the glycerol goes this side. And here during the phase separation, to get a very distinguished clear layer between fatty esters and glycerol, they will add some salts. If you add some salts, any emulsions which are there, that will be broken down. Any emulsion, because this is oil-like component, this is water-like component, there is a chance of forming the emulsion. If you add the salt, the emulsion will be broken down and there will be clear layer between fatty esters and the glycerol. So they wanted, so we'll get the fatty esters and some salts will be there. Here. Some fatty esters, some salts will be there. some salts will be there, and we wanted to neutralize those salts, or they add acid to neutralize those salts. They take it out the salts, then they do the washing and drying, and the fatty esters, the direct fatty esters used as a biodiesel. These fatty esters can be used as a or used as a biodiesel. Now, whatever glycerol and other components, they will be performed to for the, since this is a liquid mixture, using the distillation, using the distillation process, they will get the glycerol, purified glycerol, see refined glycerol, and unpurified will be used as a fluid glycerol. And again, glycerol has many applications, starting from the soaps to many other applications. We can use glycerol. So this is a way to produce biodiesel from the oils and fats. This is a way to produce the oils and fats. This is a very simple process. Now, to do this phase separation, of course, I said this is oil-like and water-like. This is not very simple gravity settling process. It has many other complications. So transesterification is simple CSTR. They will add oils and fats, and they will add methanol catalyst. This is simple CSTR. Then, if you add required amount of salts, we will able to separate fats and glycerols. But the purification of glycerol, sometimes distillation works, sometimes many other methods are used. So little difficulty only in this process, only at the phase separation. Apart from that, rest of the process are very simple. This is settling tank. This is simple CSTR for the neutralization tank, and this is simple heat exchanger used. Simple heat exchanger used to remove any amount of water present here. Then you will get biodiesel. And this is a simple batch distillation process to get the distillation column, and glycerol purification, that is to remove any unwanted, just same as here, any unwanted water to remove, then you get the refined glycerol. I hope you understand the bioethanol production from the lignocellulose and biodiesel production from the oils and fats. Now, another recent developments is that green diesel. They are called, they're producing green diesel from the oils and fats. Green diesel from the oils and fats. So this is simple hydrogenation reaction. If you react green diesel, vegetable oil, just now I mentioned here previously also, same thing, what I've got here, vegetable oil will contain triglycerides, and if you do the hydrogenation, any guess what are the catalysts used for the hydrogenation reaction from the students? You might have studied a lot of chemistry. Just to keep this in context, what is the catalyst commonly used in a hydrogenation reaction? Any guess from any student? No idea. Okay. Any metal catalyst?
Platinum, palladium.
Yes, you are right. Platinum, palladium, nickel. These kind of metals are used in the hydrogenation reaction. These catalysts. Platinum, palladium, nickel. These are the metal catalysts can be used in the hydrogenation reaction. So when you do this in the presence of those metal catalysts, if you perform this hydrogenation reaction, you will get Linear chain. Linear chain means we have carbon, carbon, carbon. Linear chain. Linear chain. Linear chain hydrocarbons are produced. You will also get CO2, H2O and C3H8 along with this one during this reaction. During this reaction. So these linear chain hydrocarbons are very good, good performance for the diesel. So it is this is called as green diesel. So typical green diesel production process. This is the typical green diesel production process. So vegetable oil and hydrogen feed to the Hydrogen and vegetable oil are fed to the reactor where metal catalysts are used. Metal catalysts are used, and here after the during this reaction you will get linear chain hydrocarbons. You will get CO2, water, and C3H8. Now here, whatever linear chain hydrocarbons, they will be in the form of liquids. They will be in the form of liquid and water. Then you will also get the gases like C3H8, CO2, and these gases goes and do the acid gas scrubbing process to separate any unreacted hydrogen. So they will separate CO2 from this because if you use any solvents like which I discussed earlier in the seed gas to nitrogen production process. If you use any base components like NaOH or something, then you can scrub CO2 or absorb CO2 from that. Then this unreacted hydrogen will be recycled back and water is taken out. And here this green diesel, we'll never get actually, unfortunately, hydrocarbons, we will never get only one component. We'll get many components. So we'll get green diesel, we'll get low molecular weight, low molecular hydrocarbon components. So we have three varieties of components. So we have to do distillation. You will understand much better in the petroleum refining process. So if you do the distillation, you will get light components and propane is taken out, naphtha is taken out, and green diesel is separated. So very simple, one reactor and a distillation column to produce the green diesel. Now what is the difference between these three components? What are the differences between these three components? So this is crude oil based, this is the crude oil based ultra low sulfur diesel. Means the crude oil which contains very low sulfur and diesel is produced from that low sulfur crude oil. If you see the characteristics, oxygen content is 0% and the sulfur is less than 10 ppm and heating value is 43 megajoules per kg and distillation rate, that the boiling point range is 470 to 620. C10 number, the diesel performance is expressed by the C10 number. The diesel performance is expressed by the C10 number. And CO2 emissions and stability. If you compare this with the biodiesel, which is produced from the transesterification of oils with the help of methanol catalyst, if you do that biodiesel or for that matter, whatever produced from the lignocellulosic biomass, it will contain oxygen. It will contain oxygen. So this oxygen helps in one way that it will enhance the combustion, but it also limits one way the reactivity of the diesel. Reactivity of the diesel. So that's how, because of that, biodiesel alone we cannot use. Rather, but one advantage is that it has low CO2 emissions than the crude oil based biodiesel. So often they mix diesel from oil based and biodiesel they'll mix and use it. They will mix and use it. Of course, some countries they make this biodiesel from the sugarcane juice, sugarcane extract, which is easily dissolvable sugars, and they'll totally use their own vehicles based on that diesel. Sulfur content is very very low. That is the very big advantage with this green diesel and biodiesel. If sulfur is very low, H2S or SO3, SO2 emissions are very low. And SO3 is very dangerous. Even if it's very very trace components are present in the air, that will cause more damage than the other pollutants. Now, heating value of biodiesel is slightly lower than oil-based one, but whereas green diesel, zero oxygen, zero oxygen, because there is no, we are completely separating out all the convert, like previously esters are there, that's why it is still oxygen is there, but here there is no esters, so there is no oxygen. So oxygen is zero and sulfur is very low and heating value is slightly better. We can say same. The distillation range is slightly higher, that means longer chain hydrocarbons are there. C10 number is higher, that means higher the C10 number, better the performance. If the C10 number is higher, better the performance of a diesel. The performance of a diesel is expressed in terms of C10 number. Higher the C10 number, better the diesel is. Since biodiesel contains higher C10 number, they'll mix some of the biodiesel with the normal diesel from the crude oil and they will use it. But green diesel still under the establishment. So of course, I hope this will come very good in the future days. So this is much higher CT number and stability of this is good and stability of this is also very good. And CO2 emissions are much lower than the crude oil based diesel. This way, we can produce using the simple reaction, vegetable oils, hydrogenation of vegetable oils to produce the green diesel and this. So these are the different ways we can produce different ways we can produce fuels, biodiesels and green diesel from the biomass components. Biomass components. So one important thing I wanted to highlight. See here, if I take this one, I have explained fermentation to produce ethanol, and I have explained one from the biomass and from the other one. Now, in the current days, a lot of research is being going in this direction because biomass utilization needs to be addressed. Excess amounts of biomass is being produced. Now, India we don't have that, but if we see countries like Finland and some other European countries, it's extensive range of forests. Even if you go to US, extensive range of forests where they wanted to see the biomass utilization. So, lot of exploration is going on to produce these chemicals. They produce these chemicals from the biomass. In theory, they know it. In theory, we know this, but commercially, industrially, how to produce are still being explored. If you ask me what is the if you ask me what is the sector in which the chemical engineering research is going on in the current days, I can confidently say major major institutes, major R&D labs are focusing on how to convert this biomass into chemicals. If you have observed in the last 2 years, I don't know how many of you have observed, in the last 2 years, companies like IOCL, which have R&D, and HPCL, there is also another big R&D, HPCL. These companies has announced many contests for the students and researchers to give an ideas on biomass conversion to chemicals. Biomass conversion to chemicals. Because I with the market is going more towards electric vehicles, with the market is going more towards electric vehicles, they wanted to they cannot shut down the whole refineries, right? They don't want to shut down the whole refineries, or they wanted to minimize the, or if they, let's say the market in future is goes down for the oil consumption, they wanted to see the alternative way to produce other things. One of the important alternative way is that these solvents needs to be produced, these chemicals needs to be produced because it has a lot of applications. So these industries in the last 2 years, maybe you can Google it after the class, they announced a lot of contests to convert this biomass to chemicals. And they have already granted so many projects, hundreds of crores of rupees value projects on this biomass chemical conversion. If someone feels interested, someone can explore in this direction, and that will be a good opportunity for you. So this book, which I uploaded or which I given, which is available to you, in that book, all these process are very explained in a detailed manner, and all these flow sheets were taken from that book only. So this is all about biomass processing. Biomass processing. Of course, I could explain this chemistry behind this, but I don't want to get into those chemistry and fundamental catalytic reactions and all those things because it's an extensive. I just want to limit it to the process wise in this course, so that's why I'm not talking about that one. So, any questions from the students? Are you able to understand, or any questions which you can ask me, as we have 5 minutes time? Since it's only 5 minutes is there, so I don't want to start the next topic or the new topic. So, if you have any questions, you can ask. Otherwise, we can stop it here. Okay. Seems no questions. As usual,